Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today to get a $20 credit and launch a new server in under a minute. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. And join the discussion at dataengineeringpodcast.com/chat. Your host is Tobias Macy, and today I'm welcoming Ajay Kulkarni and Mike Freedman back to talk about how TimescaleDB has grown and changed over the past year. So, Mike, could you start by introducing yourself?
Hi, I'm Mike Freedman. I'm the co-founder and CTO of Timescale, and I'm also a professor of computer science at Princeton University.
And Ajay, how about yourself?
I'm Ajay Kulkarni. I'm also co-founder and the CEO of Timescale. And fun fact is that Mike and I go back over 20 years where we were roommates in our freshman year of college. We actually met the first week of college, and I actually even remember the exact moment we met, which I think is pretty crazy.
And for anybody who hasn't listened to the first interview where you guys showed up on the Data Engineering Podcast, which there'll be a link to the show notes for people who want to catch up, can you just give a quick refresher of what TimescaleDB is?
Of course, yeah. So Timescale, we're an open source Timeseries database. In particular, we are the leading open source Timeseries database that supports full SQL. We're engineered on top of Postgres. So what that means is that we look and feel just like Postgres. And we also inherit all of the storied Postgres rock-solid reliability, and of course, its massive ecosystem. That also kind of gives us the largest ecosystem of any time series database, despite being only 2 years old. We launched less than 2 years ago. We've raised financing from top VCs since then, including Benchmark, NEA, Two Sigma Ventures, and a variety of angels. I think since we last spoke, some new things are we've surpassed 1 million downloads. Our production users include, companies like Comcast, Cree, which is a lighting company, Leica, which is an animation studio like Pixar. We're even deployed by the European Space Agency for a new solar orbiter mission that they're working on. And also, I think that kind of some of the newest news is that we found out recently that we are the most requested extension on AWS RDS, and we're the most requested feature on Azure Postgres. So I think this all speaks to not just the product we've built, but also I think, the kind of the broad adoption and popularity that it's seen.
Yeah, I know that last time we spoke, I had been asking about the availability of Timescale as an extension in RDS. So with the level of support that you're seeing on that front, hopefully it will come to fruition in the near future so that I can add you to some of my databases rather than having to spin up EC2 boxes and run it myself.
Yeah, we a lot of that is out of our control because we don't run RDS. But what I will say is fairly soon, we can talk more about this later in this interview as well, but fairly soon we'll have a managed offering, a fully managed Timescale offering that you'll be able to just, you kind of use like an RDS on AWS.
And when you first launched, time series workloads were something that were widespread and used in a number of different contexts, and there were some existing databases on the market for that type of workload. But over the past year and a half, the need for time series data and the prevalence of it has exploded beyond what it was 2 years ago. So I'm curious what you have seen in terms of shifts or new entrants to the market and just the overall ecosystem of time series data and how that has grown over the time that you've been working on Timescale.
Yeah, I mean, I think when we started the company, we had, our main hypothesis, or at least the problem, the itch that we needed to scratch was that there's a lot of time series data, but none of the existing time series databases supported SQL. So it's really this intersection of time series and SQL, and in particular Postgres. And I think just in the past year, like the trends have grown, to be honest, like even faster than we expected. Time series, continues to grow as the fastest growing category of databases. Postgres continues to grow, and I think for the second year in a row, is the fastest growing database, according to DB engines. And number two is Mongo. If you look at Mongo stock, you can see how well Mongo is doing, and Postgres is no, quote unquote company behind it, but Postgres is apparently growing even faster. And so we continue to see that. I think what's been interesting with time series is that Initially, the premise was that, there's a lot of time series data in, say, kind of IT operations and DevOps, a lot of time series data in IoT. And I think we're seeing that, but like even more than we expected. I think the DevOps world is growing faster than folks expected. I think in IoT, whether it's industrial machines or sensor data or oil and gas rigs or historian data or some of these new IoT devices, I think it's all grown. I think the data volumes are growing faster than we have seen. Than we expected. So I think it's been really cool. And I think that explains a lot of the adoption we're seeing. Time series also, it is managed to crop up in places that we did not expect. Like we see companies deploying us as part of their ML pipelines, as part of their web and mobile eventing data, and part of their security analysis. I think network monitoring is something we're seeing a lot of usage from that we did not expect. When we started this company, so it's all been good things. I think in terms of the market, I think probably the most interesting news has been, as of a few months ago, when AWS at reInvent announced their own fully managed time series offering called Timestream, and I think that's been interesting for like a couple of reasons. Number one, I think it did totally validated the market, and I think a lot of people, when the news came out, a lot of people asked us, "Oh, is this going to hurt you guys?" And it's actually only helped us. Like, we've only gotten more attention from potential users. We've actually had analysts, like leading database analysts, like cold call us to talk to us, and like, "Oh, hey, we're having a lot of conversations lately that where Timestream comes up and Timescale comes up, and can you talk?" And we're like, "Yeah, of course." And in fact, we've also had a lot of inbound investor interest as well. So I think that's been very validating. But I think the really interesting part about Timestream is, when it first came out, it was really just kind of funny because we saw the name and we were like, "Wait, Timestream? Did they really call it that?" And because we're Timescale, and when we saw some of their marketing as well, when we looked at it, we're like, "Wow!" It very it kind of mimicked, to put it mildly, our own kind of marketing and our own messaging. And we talk about some of the things we talk about in our blog posts and our website and our kind of talks we give that are also on, available on YouTube. Even though the product is very different, I think a lot of the messaging they adopted, they kind of adopted from us. So, when that news came out, I think we all found it very flattering that, like a company with essentially unlimited resources like Amazon, when launching this new time series product, felt the need to copy us. And we're still like a 30, 40 person startup. And I think we found that really flattering and pretty funny.
Yeah, it's definitely interesting the ways that AWS can influence the perspectives on what people think they might need for their given workflows. And as you said, having them launch a managed time series data storage system definitely validates the niche that you are working to fill. And another reason that I think that time series has become more prevalent is, as you mentioned, customer analytics and some of those types of data, but also a much bigger shift from some of the batch-oriented Hadoop-style workloads to some of the more continuous streaming analytics powered by systems such as Spark or Flink and things like Pulsar and Kafka, and just that view of needing to have everything be real-time and up-to-date, and having the, as you mentioned, SQL interface on top of that time series data makes it much easier for people who don't necessarily have as much of the technical acumen as the data engineering or data science team, still being able to have self-service access to that data with a minimal amount of processing necessary.
Yeah, and I think that's one of the advantages we've always seen from, and what we hear from customers as well, of our approach compared to some of the others where they were building their own custom query language, was that as you point out, that not only is SQL broadly adopted, but you have this existing large install base that speak SQL natively, and so it's not just that both people are trained to use SQL as one of the largest data access languages, but also visualization layers and existing legacy applications. So you can basically use this time series data and join it with other business data and metadata, and then use it across your entire organization. And I think related to your questions before too, which is one of the things that we've seen is a lot of the existing time series databases had come out of this IT or DevOps world where they were kind of narrowly focused on the use case. What we start seeing is as more and more companies are starting to use their time series data as part of their digital transformation, that they need a much richer use of this time series data than these previous solutions that had been built only for IT ops really offered, and they get that through the flexibility that we have at Timescale.
And also, I mean, just to kind of close out the AWS thread, I think what's really interesting is you're right. I think AWS, I think they've done a great job, kind of building, to some degree, the whole cloud or hosted industry, and they do kind of direct people. And I think what's happened is that people saw TimeStream like, we need something like for our time series workloads. But then they kind of looked at kind of the pricing and how TimeStream worked. And if you actually look at it, it's actually quite expensive. It's not really designed for operational workloads. It's kind of this weird serverless thing that maybe it's built on Kinesis or something. We're not exactly sure, but I think people have said like, oh yeah, we have operational workloads. Oh wait, like we can't that kind of consumption model doesn't work for us. And then they've come to us, which we're more of we're like a real database company. And I think it's really worked out. And plus the advantage of working with, a company like Timescale is that we're cloud agnostic, and so you're not tied to AWS. You can essentially have workloads on AWS or Azure, or GCP, or whatever you want. And I think that's kind of been a driver.
And also having the AWS managed offering limits some of the capacity for doing local development. So being able to install Timescale on a developer's machine to build out new features or test out new capacities, and then being able to launch that to whatever their production environment is, simplifies the overall life cycle of building different features and products that actually leverage that time series data. And over the past year since we last spoke, I'm wondering what has changed in terms of the focus and features of the TimescaleDB project and the company that you've built around it.
Yeah, I think last year the big push was getting towards 1.0, which we launched in September, October. And 1.0 is a really kind of a funny thing for us because typically databases become 1.0 when they're production ready, but being engineered on top of Postgres, we've been production ready since essentially month 3, if you will. So like pretty early from version 0.1, I think. And so 1.0 is really just a kind of our stake in the ground and public recognition, saying, hey, we're not just production ready, but also enterprise ready. I think the focus for this year, which I'll let Mike talk about in a minute, has been some kind of the next phase of the database, both in terms of kind of capabilities, but also consumption models.
Yeah, I think there's 2 main capabilities that we've been working on and have delivered part of it. Talking about the database itself, there's really been 2 large focuses. One has been kind of a whole automation framework that we've built into the database, so that not only typically you consume a database by sending queries and inserts, but now we've basically built this rich automation framework inside the database, whereby the database will in the background, continuously implement data retention policies, will reorder your data in certain ways to make your query much more efficient, and will allow you to do continuous segregations where you'll continuously roll up, from raw data to aggregated data to, on a raw data to 1 minute intervals to 1 hour intervals to both make queries much faster, and deliver that all the way that you could set up a very simple policy, and the database will continuously do this in the background. Some of this automation framework and capabilities have already been released, and we're basically releasing new capabilities for this, particularly around the continuous aggregations over the next couple months. The other big focus that we've been doing from a product engineering perspective has been building out basically our scale-out clustering capabilities. Right now, we offer clustering in the form of a single primary multiple replicas. And so people regularly deploy that both for high availability and fault tolerance, and also as a way to kind of scale out read capabilities. So you might, for example, give a read replica to a data science team or an analytics team where they could, hit it with all your random expensive queries that could be, scanning the entire database while you're continuing to drive high write rates at the primaries. But what we'll be basically releasing throughout this year is the ability to scale out the number of primaries you have. So you could build out this to the hundreds of terabytes or petabyte scale, as opposed to today, which we generally see people in the tens of terabyte scales.
One more thing that I think is worth mentioning is, because it came up kind of earlier in this conversation, is we fully recognize that not all, but I'd say a lot, maybe most database workloads are moving to the cloud. And I think like you kind of alluded to, it's like not everyone wants to manage a database on EC2 or on their own VMs, and so we fully recognize that, and so our managed offering right now, which essentially has been in beta, where over the next few months you'll see more announcements around this, but one of the main focuses has been is really bringing a generally available fully managed Timescale cloud that essentially allows you to do the things you want to do, which is insert data, query data, analyze data, use the power of SQL, and maybe kind of let you offload things that maybe folks don't really want to bother with, which is backups, replication, just kind of operating the database. And the way we're thinking about this managed offering is really to have something that's not just tied to one cloud provider, but is really available on multiple clouds. But again, we'll have more, I think, to announce in the next few months.
So last fall, you launched your 1.0 release, and you talked a bit about the criteria for establishing that milestone. And in around that same time frame, the PipelineDB project also hit 1.0, and their focus is on doing these continuous aggregations in memory on top of Postgres for high volume workloads where you don't necessarily need access to the raw data, but you want to be able to continuously query these aggregated data points. And what you were saying, Mike, as far as introducing some of the automation around timescale of continuously computing these aggregates and these rollups, I'm wondering how that plays into the calculus that somebody might be doing as to whether they would want to use PipelineDB versus TimescaleDB for some of these aggregated statistics.
Yeah, we definitely are familiar with the PipelineDB product and think it is very good for the workloads that the use case that it's come out with. I think the great thing about 1.0 was they actually moved from a Postgres fork to Postgres extension, and we've certainly we've heard some requests of people looking at using both type of products. I think one of the main ways that these are looking at really complementary problems rather than competing problems is that, as you point out, that pipeline is really designed for these workloads where you have a really high volume of initial requests, but you don't want to basically store all the raw data. And so typically the way you're deploying this is that you kind of buffer a lot of these initial data points in memory and then into little micro batch. And then on that micro batch, then you update just an aggregate that's stored as like a view in the database. And so, I think one of the main ways that we're different is as much more of a traditional transactional database where you could use us to store your raw data as well as do all the type of transactions that you associate with a relational database. And yet also in the background, this new automation capability, be able to continuously create aggregates. And one of the reasons that you use aggregates is then you could then power dashboards where, for example, if you're trying to compute a statistics over a week-long data with millions of data points, you don't always at query time want to recompute, touch millions of data points to compute that one metric. You'd want to just power it on the pre-aggregated data. In that notion of allowing queries on pre-aggregated data, it's similar as pipeline. I think one of the ways that pipeline is different is they're really looking at things where you might be pushing, I think sometimes for the simpler case, tens of millions of metrics per second on a single machine, where I think right now we're kind of at like 1 million metrics per second or so on a single machine, because you're not actually storing the raw data. In a lot of cases, there's this long history of various type of streaming algorithms or sketching algorithms where you're doing these type of approximations or various type of functions where you can't even really store. You're only computing an approximation of the actual results because you're, again, not really ever looking to store the raw data.
I would also add, just on a non-technical side, we're also big fans of the pipeline team and the work they're doing. And we think it's great for not just the Postgres ecosystem, but also for, I think, data management in general.
And going back to your 1.0 release, I'm curious what were the most challenging aspects of establishing and reaching that milestone and some of the outcomes that you've seen post 1.0 in terms of general recognition or curiosity of the product and the work that you're doing at Timescale?
Yeah, I mean, to be perfectly honest, I think the hardest part for us is where to draw the line and say this is 1.0. Because, typically companies like, oh, like until we're production ready, we're not one. But we've been production ready for, at that point, like, over a year, So we were kind of like, it was almost like scope creep. It was like, hey, like, where do we internally say, okay, now we're drawing the line and this is 1.0 and everything after that is not 1.0. And some of that was, I think, pretty clear around some usability things we wanted in 1.0. And other things were less clear because there are capabilities, and some of it we're like, hey, you know what? This can come in 1.1, and that's fine. But I think the key thing is we did want to get that out the door and to essentially establish that, yes, this is production and enterprise ready. In terms of beyond 1.0, I'll let Mike maybe.
Yeah, the other interesting thing about doing a 1.0 release is that, in one of the things that we always thought was very important from the start was to deliver, given that Timescale is implemented as an extension of Postgres, basically enabling, the as close to full capabilities of Postgres as makes sense for a time series database. And if you think about what other time series databases offer, they're like, well, we'll be SQL-ish, which will be a very simple select statement that maybe could only order by time and can't do anything else. That's what, for some people, a SQL-ish language looks like. For us, we have, part of the 1.0 process is really to kind of almost cover the broad scope of every various combination of what Postgres allows you to do. And, given that it's a 20-year-old database, it often lets you do similar things in multiple different ways. So, we'll occasionally, I remember at one point we had a bug which was caused by somebody having a trigger inside a subquery of a common table expression inside a null query. And you compare this against a SQL-ish language, which only allows you to order by time. And so the level of complexity and maturity in what we want to deliver on was much larger, but also, like, in order to declare this stuff all work, it's just there's a long tail of things that we needed to meticulously go through and check.
I mean, I think no other time series database has that problem because no other database can actually do anything close to that. And for us, we're like, oh, like we can do 90% of it right now, but we got to really work out this 10% corner case. And then there are quite a few of those that we managed to kind of iron out before 1.0.
And in terms of the contract that you're putting forth with that 1.0 release, is your intent to say that from this point forward, there is this baseline set of features that we will always support, or at least until we deprecate them in 2.0? And what are some of the things that were most requested as far as having that level of commitment in terms of feature support?
I think related to what I was talking about this long tail is, our focus with 1.0 was really to give people the perspective that they already know how to use the database. And that means from both the user's perspective and the operations perspective. And, as it really looks and feels like Postgres, even though it has, a lot more capabilities, both from a scaling and performance perspective related to time series data, and also, new time series manipulations that we didn't have before. We actually viewed that as a more critical part of 1.0 than kind of the next stage of special features related to time series, like clustering and automation. And you'll see in one of the next releases we'll have kind of new capabilities around time series analytics for gap filling and OLCF and interpolation, which should be out in a couple of weeks. So we really viewed that 1.0 was giving people this familiarity that we will continue to want to will maintain going forward, as opposed to necessarily new features.
And as you have continued to build and grow Timescale and work with your customers, what have you found to be some of the most challenging types of time series workloads and some of the differences in requirements of Timescale and the underlying Postgres as far as what those workloads dictate?
So one of the interesting things we found is that, particularly in being a again, general purpose database, we see a lot more varied use cases than you might see if you were specifically focused on something like DevOps. And even in an IoT, for example, is one use case we see a lot. But even in IoT, you actually see very different data patterns, which actually often mean a different way you use the database. And I'll give you kind of three examples. So one common IoT paradigm is that you have many different, a lot of homogeneous devices. You have the same device deployed in thousands or tens of thousands of locations, collecting data all at the same rate. And so then that dictates one type of data model to store. You put all of this data in a single hypertable. You could predefine your schemas up front because all of your devices are very similar, and it's kind of the very natural thing. Another use case is that you will actually have a broader system and different types of sensors that are collecting different data at different offsets. And so that, again, basically leads to different types of data models that you want to handle inside your system. And there's different ways that you could use Timescale to store for, either defining different data, sensor types, or using our support for almost like a NoSQL database using JSON B support. And so what we find is that even in an area that you think sounds like kind of quote IoT, there are many different types of deployments that lead to different ways you use the database. Thankfully, because Timescale is incredibly flexible in the way you could use it, really doesn't dictate a specific storage paradigm or data model. It allows people to really adapt it to their use case.
And as far as any initial assumptions or approaches that you built into Timescale when you first began working on it, what are some of the ones that have held true throughout? And which are the ones that you had to reconsider as you were presented with some of these different use cases and challenges?
Yeah, I mean, I think the number one thing that's held through throughout is this notion that people like SQL, that people know SQL, that SQL is easy to use, and it's not just for your transactional workloads, but even for time series. Is that the versatility, the flexibility, the ubiquity of SQL is something that people really wanted, and really no time series database before Timescale really did that, and that's kind of what kind of when we launched, some people thought it was heretical, but I think that's I think we thought it was true then, and I think it's even more truer now. I think probably related to that, one thing that has been disproven, and I think we're pleasantly surprised by this, is that we thought SQL was a query language for, say, software developers building applications or folks in IoT, and we just assumed that folks in the DevOps and IT monitoring space just didn't like SQL. Like they wanted something that was more bespoke and custom, like. And one thing we've been pleasantly surprised is that there are actually quite a few use cases within the IT operations world that people need SQL. We've especially larger companies. There's this idea that you have assets that are generating time series data, and then you have metadata that describes those assets, and you need to join that data, and you don't want to denormalize it, right? And I think another use case has been you have all this IT operations data that maybe you're displaying in a dashboard like Grafana, but then you also need to make that same data available to business side of the house, either for budgeting reasons or capacity planning reasons or for strategic reasons. And the business side of the house uses Tableau, and so you need a SQL interface to that same data. And I think that's we've seen that quite often. And in particular, you see that with Prometheus. It's like maybe Prometheus is great for monitoring for the DevOps team, but as soon as you have multiple Prometheus instances, what's your long-term store? And if you want to make that data available to the rest of the organization for either business needs or data science needs, how do you make it available? And the answer there, really, I think we've been surprised. It has been SQL, and that's kind of where we've seen some usage that we did not expect.
And since we last spoke, there have been a couple of major releases of Postgres in the form of 10.x and 11.x, and those have brought in some new capabilities as far as partitioning and some of the time series type data manipulation within the vanilla release of Postgres. So I'm wondering how those changes and evolutions of the underlying project have impacted your development of Timescale from the architectural approach and any code that you have maybe been able to discard because it's implemented in vanilla Postgres, and maybe some changes in perception as far as the necessity of timescale for certain workloads?
Yeah, I think, first of all, one of the nice things about being built as an extension is that, when Postgres 10 came out last fall, we released support for it, I think, just a few weeks later. And I think about a month or two ago, we launched support for Postgres 11. And, one of the nice things is that we could take advantage of many of the capabilities that they offered. So, for example, Postgres 11, we now have support to do greater forms of parallelization across our multiple internal chunks. We have the support to use its just-in-time compilation for larger queries, and that's all been great. And so to take advantage of the parallelization and JITting and everything has really been a big win, and we definitely see. I think Postgres 11 was one of the definitely recently a oft-requested feature for Timescale. As of yet, we haven't changed the way we do internal partitioning to reuse any of the support that has been built natively into Postgres 10 or 11. In the future, we might look to see about re-architecting anything, maybe when Postgres 12 comes out. Although I think there's also very other interesting things in the Postgres roadmap that we're actively looking forward. For example, some of their pluggable storage APIs or new pluggable storage backends, which look very interesting to us. One of the particular reasons is I think that ultimately, the scale that we're looking at doing partitioning in Timescale is just much greater than I think most people use in traditional workloads you see on Postgres, where you might have tens of partitions or more. When we're seeing people or hundreds, when we're seeing tens of thousands. And so a bunch of the performance optimizations we've done, and we did spend some time looking at the implementation, but we kind of came to the conclusion so far is the type of performance optimizations we really have done, we have built are better suited for the type of the scale and needs that we have for many of the time series workloads we see.
I mean, we love all the improvements that are happening with the core Postgres, and like mentioned, we benefit from some of them. But I think the truth is that the problem that the Postgres community is solving is a different problem than what Timescale is solving. Postgres is still looking to be the number one OLTP database, and I think there's still a long way. I mean, it's growing very quickly, but it's still a long ways to go to replace all of the Oracle legacy workloads. And I think the roadmap to do that is a very different roadmap than what we're building, which is the best time series database that supports SQL. Obviously, there's some overlap, but I think especially as we grow, you'll find that there's going to be a lot of functionality that just doesn't make sense for it to be in Postgres core. And there's certain things that we will prioritize that it would just not make sense for the Postgres team to prioritize, because you just don't need these types of capabilities in an OLTP database. But for time series, they're critical.
I think these are complementary. The fact that Postgres built an extension framework means that we have the companies or projects like ours have the capability to take Postgres into new areas that it otherwise wouldn't have seen use in. So I think it's great we certainly benefit from the Postgres database, and I think the broader Postgres community also benefits that projects and companies like ours and Pipeline are taking Postgres to be used in cases where it otherwise wouldn't see use.
And looking forward, you've talked a bit about some of the features and products and capabilities that you have in the works, but what are some of the other things that people can look forward to in the future of the Timescale product and organization?
Yeah, I think, well, first, just to reiterate, I think the ones we listed so far, I think, number one, we've been focusing on a few major initiatives. One is the scale out version of Timescale, which right now we scale reads, but now it's also scaling out writes as well across multiple nodes. I think number two has been the kind of the managed offering, which we'll announce soon. Number three has been kind of automation around kind of data lifecycle management, whether it's aggregations, retentions, other types of kind of performance-based optimizations. More things around analytics, around kind of analytical offerings like gap filling, LOCF, interpolation. But those are all features. I think the key thing that we're finding is that, and I think what Timescale is headed towards is I think this company, when this launched, it was launched, I think on a simple idea. The idea was just that, hey, time series data is growing and it needs a SQL database. And I think pretty early on, based on all the broad adoption that we saw, we had, which at that point we thought was a really crazy idea, but now I think it's becoming less and less crazy. And the idea is that in fact, time series databases are growing not just because of DevOps and IoT and maybe ML and usage data, but because fundamentally all data is time series data. And it's this idea that every data point has a timestamp, and and we would argue that by not storing your data with its raw timestamp form, you're actually throwing information away, because it's only by storing data in a time series format you can actually see how your data set's changing over time, how your users are interacting over time, how your vehicles and assets are moving across time and space. And I'm not saying that you need a time series database for everything, because no, of course there'll be some workloads where you need a key value store, some workloads where you actually need a distributed OLTP database. But your workloads are fundamentally time series in nature. And because as storage gets cheaper and cheaper, and as computation becomes more and more powerful, there's tremendous value in storing your existing data in its raw time series format for analytical purposes. So you can see not just how what's kind of analyze the past and monitor the present, but even predict the future. And I think one thing you'll find not just this year, but the next few years, is in terms of how this company is going to grow, is it really helping not just with the existing time series workloads, but with other workloads that, where they converted to the raw time series, kind of format, could really lead to some really, opportunities to drive efficiencies, to launch new products, and can really, in kind of really meaningful and impactful ways.
And are there any other aspects of the Timescale product and company and time series data that we didn't cover yet that you think we should discuss further before we close out the show?
I would say the company is growing very quickly. Roughly in the past year, we've almost quadrupled our headcount, and I think that growth is going to continue. And so, and at this point, I think maybe a year ago we were predominantly in New York, but now our team is distributed across everywhere. From on the West Coast, we have folks in in Portland, San Francisco, LA. But even if you go east, not just in the East Coast, but also in Europe, we have teams in Stockholm, in Germany, even in Macedonia and Moscow. So I think one thing about Timescale is we're growing very quickly. We are hiring across the board with really strong engineers, but also really kind of really strong business folks who are really passionate about databases and open source. I think. If you're anywhere in those time zones, we'd love to talk to you.
All right. Well, for anybody who does want to get in touch and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I would like to get the perspective of each of you as far as what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, I mean, I think we're really at I would say an inflection point, or really a crossroads, if you will, in the database data management world. More and more workloads are moving to the cloud, and plus you have the rise of open source. In a kind of contradictory way, the rise of the public clouds has actually it's kind of been a threat to the rise of open source, and you can see this as folks like Amazon launch proprietary products on the backs of open source communities without really contributing back to the communities. And in fact, the products they're launching, they're not open source. I mean, they're proprietary. And I think that is maybe not a product that's missing, but I think that's really, I think that is a missing thing in the community, which is, how do we marry the rise of the cloud with the rise of open source? And if the answer is multi-cloud, I don't think anyone, has been able to provide a really strong multi-cloud story yet. I know some vendors do it, but I think that's a kind of really big question mark in my mind.
Mike, do you have anything to add?
Yeah, I think one of the, if we think about different use cases, we definitely see a lot in IoT. And one of the interesting things about IoT is it goes everywhere from the edge to the cloud, where people are looking to build more pipelines where, not only are they trying to transmit data from the edge to, let's say, historically, you might use a data lake or something where you're just running non-real-time reporting. But now that they want to operationalize the data, they want to, deploy a time series database in the cloud to be able to operationalize that and make that more real time. But we're also seeing where actually they deploy us on the edge too, because it's not cost effective or for a variety of reasons to constantly stream all the data back to the cloud. And so part of this now enters this management. We're now beginning to enter a plane of how do we do data management all the way from the edge to the cloud, where you have lots of different instances of your database that only include a subset of your data. And in general, there is not really great tooling out there or great frameworks out there to think about data lifecycle management across and really just the control and security of across data across this big hybrid platform.
All right. Well, thank you both for taking the time again today to talk to me about how Timescale has been progressing over the past year. And thank you for all of the effort that you're putting into the product. It's definitely very compelling and one that I've been keeping a close eye on for a while now. So thank you for that. And I hope you both enjoy the rest of your day.
Yeah, appreciate that. Thank you for having us.
Thanks a lot for the time.